A fun demonstration today. We are going to be creating a Cline skill that lets us flash ESP32 boards and use them for a variety of fun purposes. We recently released a Platform IO MCP server, which allows us to directly interface with Platform IO, a common board flashing platform. This plays quite nicely with Cline as well, as it lets us effectively vibe code hardware. Without further ado, let's jump right in. So the key here, and the main thing that we're trying to get out of this, is we are wanting to create a skill that lets us work with and create ESP32 based BLE sniffers, complete with a nice cyberpunk interface for us to work with. So we are basically going to be creating the header and metadata for the skill. We have an overview of the project, and of course we are feeding in step-by-step instructions in order to be successful with this. This plan honestly looks good to me, so we can let her rip, if you will. Something to call out as well is that this was a completely blank and empty directory. There is nothing in this as of right now. We are starting from scratch and playing by the rules that way. Perfect. So we now have a comprehensive markdown file of the explanation, the project overview, and the skill metadata as well. This is key because this will be what we use to create this skill. Amazing. So with that, we have our skill file created. Basically, this contains the complete metadata, instructions, and source code required to build our BLE sniffer with our nice high-end cyberpunk web interface. Let us go ahead and execute on this. Okay, so now that we have this project basically scoped out, as well as the skill created to execute this project, we're going to completely implement this project. We're defining done as this board is flashed, and we are confirming that we are seeing output to this board through the web interface that we put together. Thankfully, all of this can be done within Cline. The main.cpp file, or C++, is our main implementation that we have here. This contains the configuration regarding the device, the BLE device data, as well as the structure that we anticipate from this, as well as the web UI content, which again is completely hosted on this device. Love you, Vercel, but not needed this time. So as we go along, we do have some minor errors and compilation issues, but Cline is chewing through those and resolving them in real time. We're just adjusting the baud rate now, as we're having some minor issues with the compilation and flashing process. It looks like we are now successfully flashing this chip. It takes a few seconds to write, but we are working through that. We're actually going to change our approach for connecting to the Wi-Fi. Rather than have its own AP network, we are instead going to pivot to utilize the actual Wi-Fi that we have in place. Benefit to that, of course, is that this particular device will just be a lot easier to discover. We won't have to deal with the fact that we won't have internet while connected to the device. Overall, it's just a lot cleaner for our purposes. And we have successfully written the device. Perfect. Now we have successfully flashed it. Cool. Oh, wow. And we are seeing quite a few entities right now within our purview. It looks like we are seeing quite a few entities. And these are actual Bluetooth devices that we are scanning from our immediate surroundings. It is just blasting our terminal with it. Guess there's a lot of people near me. I think we can go ahead and proceed while running. I think it probably has enough context of what devices might be nearby in order to proceed. You can see our Bluetooth chip on here is quite active. It's flashing blue. hilariously, as it is being utilized and activated here. Okay, we've successfully flashed our board with some minor updates to enable access to the web UI that we want to utilize. And we are now checking the dashboard. Mind you, the interesting part is that this entire thing is hosted entirely on this board. There are no external dependencies that we're utilizing for this purpose. Oh, that looks wonderful. So there we have it, a lovely web UI for the devices that we have detected on the network. That's so fun. Cool. Well, with that, it seems as though our work here is completed. We are effectively sniffing for any and all Bluetooth devices on the network that we currently are nearby, or that are just near, because that's kind of the way that Bluetooth works. And we are showcasing it all on a nice, lovely web UI. Throughout this process, we built and referenced constantly this ESP32 BLE sniffer markdown file. That includes the Cyberpunk web interface. This includes the necessary information to create a client skill, including the title, description, tags, prerequisites, and so on and so forth. This is really the bulk of creating a Cline skill, especially one as extensible as this one. So with that, we have successfully reflashed the board, and we are again able to see our Cyberpunk UI for all the detected devices nearby. Amazing. So we have successfully completed the task. Our Bluetooth sniffer, which can find Bluetooth devices nearby, is fully operational and flashed to the board. We successfully created a Cline skill through this process. That was kind of our source of truth for creating this relatively complicated implementation. Our firmware compiled and uploaded successfully, and we have a nice, lovely web interface. A closer look at the web portal that we created. We have our BLE sniffer UI here. These are the devices that's detecting nearby, most of which are unknown, and this is the signal strength by which we can detect them. We are displaying them by order of when they were last seen. And with that, we have successfully vibe-coded hardware using nothing but Cline, the Platform IO MCP, as well as some good old-fashioned sweat and tears.